And angles can have effects on loads. And there you have a summary of OSHA employer responsibilities. If you look back on your outline, after all of the references to technical issues are listed, we come to a sub-item B, which refers to Appendix A of Subpart C, Soil Classifications. Now, what this has to do with is the idea of excavations, and the general rule of thumb is this: if you excavate more than 4 feet in the ground, you need to give a person a ladder, a way out. If you go more than 5 feet in the ground, you have to consider what happens if you try to dig in the sand at the beach. When you do that, the soil collapses backwards. Now, sand is a particular type of soil and will collapse back a lot faster than, say, solid rock that won't collapse back at all. And so depending upon the soil that you're in, the tendency of the soil to cave in will change. And there are rules of thumb as to how to excavate given the type of soil that you're working in. And in the CRAM manual, there is a topic called an OSHA pit. And what we're talking about is a rectangular excavation. And the idea is that in this type of solution to how to keep it from caving back in, you're going to taper back the upper edges of the pit in all 4 directions so that the soil will not cave in as you go deeper. Now, the rules are that you can go from 5 feet to 20 feet by using this arrangement to taper back the pit. Other ways to handle soil caving back in, of course, is to shore up the ends or shore up the sides, or use corrugated metal, something we'll discuss in vertical construction techniques. But if we're just digging in the pure soil, we would want to taper the sides back to accommodate the soil conditions. And there is a math question that's asked on the exam often about the amount of excavation of this OSHA pit. This is also described in the site work chapter of Walker's and in the CRAM manual under OSHA pit. And you're going to want to take a look at this calculation and figure out how to do it. But before you get into the calculation, it's important that you really visualize what's going on. So sort of get the idea of how a pit could be feathered back in all 4 directions. If you really visualize it, you'll find it relatively straightforward to do this calculation. And the long and the short of it is that in a normal excavation for a rectangular pit, the formula to calculate the volume would be length times width times height. And in an OSHA pit, that formula becomes average length times average width times height. And the rest of the story is explaining how you go about finding this average and what that really means. The last topic dealt with in the technical side of OSHA is dealing with hoists and rigging and rope types. And this is kind of an involved and elaborate chapter or section. And in my book, it begins at the end and goes through to the end of the OSHA section. And it starts in my book on 7113. So if you'll turn to 7113, we'll take a look at some of the important issues here. On 7113, they list 12 questions, which are the basic, or 13 questions, one going to the next page, which are basic questions that you'd ask about a rope to determine whether it was suitable for the type of work that you were thinking of doing. And now what they're going to do is they're going to go through the types of ropes and list advantages and disadvantages of the different types of ropes. For example, on 7-114, manila rope is described, and item B, bolt rope, it indicates that bolt rope is stronger than manila rope by 10 to 15%, and then they differentiate the grades of this manila rope. Now they're going to talk about manila rope construction, how it's built. They show you a picture of how it's wound, coiled, and then the next page talks about the care and storing of this type of rope. And on the next page, on the right-hand column of 115, where they're talking now about synthetic fiber rope as a replacement for manila rope, they indicate that these types of synthetic fibers are lighter, easier to handle, and usually will outlast a manila rope by 4 or 5 to 1. Now they describe nylon rope and indicate that nylon rope has a degree of stretch from 10 to 40%. And also, nylon rope will retain physical properties almost to its melting point, which they indicate is above 300 degrees Fahrenheit without serious material loss, and then or strength loss. And then on the next page, they indicate that these ropes do become slippery when wet, and they also lose about 10% of their strength when they get wet as well. On 717, they describe characteristics in general of rope. And what they're going to talk about essentially is something called a breaking strength, which is the strength at which the rope would break. Then there is a working load, which is a calculated point or a calculated load that the rope is okay to work with. And then they're going to talk about a working ratio, which is the relationship between their working load and their breaking load or their breaking point. And the idea is this: you do not want to use a rope at where, if a rope would break at, let's say, 1,000 pounds tensile pressure, you don't want to lift 1,000 pounds with it. You want to give yourself a safety factor. And what's important here is there's a different safety factor if you're lifting materials and a different one if you're lifting people. And on 117 on the upper right-hand column, it indicates that if you're lifting materials, a safety factor of 5 is okay, but if you're lifting people, you want a safety factor of 10. And they show you a couple of boxes that have formulas for how to calculate the breaking strength of rope. And then they show you on the next couple of pages some tables that you could use. And finally, you get to 7120 that shows you how actually to calculate this if you didn't have a table available and if you knew the type of rope you were working with. For example, if you look at the upper left-hand corner box, a nylon rope, it tells you that you take the size of the diameter of the rope and convert it into eighths of an inch. And then you square the numerator and multiply by 60. And they show you how to do this. And so the test might ask you to calculate what the safe working load calculation would be for, say, a nylon rope. And they would give you the diameter. You just have to plug in this formula to find out what that would be. On the next page, 121, they start talking about how to safely maintain and keep ropes, and keep them dry, never overload them, and so forth. And that's pretty self-explanatory. On the next page, they tell you and show you diagrams of how to handle them and how to store them. And then they go into a rather elaborate discussion about splicing these ropes. And on 123, they show you different types of splices, and they show you pictures of how this would be done. On page 124, they show you a long splice. Of course, the short splice was what they showed you on the previous page. And the short splice, I believe, is the one that is the strongest on 123. And then they show you the long splice on the next page. And then on 125, they have the side splice, which they show you here. And then the Flemish eye splice on the lower right-hand corner. And again, here, you're not going to have to memorize this, but you may have to answer a question about the type of splice and which one is the strongest, for example. Then we get to page 126, and what is important here are knots, bends, and hitches. And on the right-hand column of the top of 126, they indicate that knots and bends reduce rope strength by about 50%, and hitches reduce rope strength by about 25%. Then they show you different types of knots. If you were a Boy Scout, this will bring back memories to you. And then they go on to page 129 and start talking about general safety requirements with individuals handling weights and lifts and ropes. Then they get to page, well, actually that same page, going on to 129, they go to 130, and now they're going to talk about wire rope. And again, they're going to do the same thing they did with fiber ropes. They're going to describe them, describe differences and characteristics, describe breaking strengths, safe working loads, and how to find these sort of things. And they show you the same kind of formulas you saw before on 132, except now they introduce the phrase catalog strength, the catalog breaking strength, same thing. And then they show you a table on 133 about these things. And now they're going to go into the types of fittings that are used with wire ropes, and that starts on 135. And they show you pictures of them and list different types. Then on 137, on the left-hand side, they show you a correct and incorrect way of clipping these ropes together and using spliced eyes for the ropes. They describe how you unwind these ropes. On the next page, they show you how to seize these ropes. They show you some pictures here of how to seize them. Then they talk about lubricating them and breaking them in. And then finally, they have a checklist for inspection. And these are pretty useful tips, by the way. If you think about it for a minute, you'll hire a crane to come out there, and you're relying on the crane company or operator to make sure that the ropes are in good condition. Well, if something falls down and hurts someone, they may indeed question such people, but the person that's going to be responsible is going to be the GC. So you might want to get used to how to look at ropes just to get an idea if there's anything that looks dangerous that you can prevent the problem from occurring. Okay, they're also on page 141, they tell you how to wind these things and the correct way to wind them. They also, on the previous page, 140, describe something called a ratio A. And ratio A is dealing with block sheaves, and it has to do with the relationship between the sheave diameter and the rope diameter. And what's going to happen is the ratio is going to affect how strong the rope is. And they show you a little table that says, well, look, if you've got a ratio A of 40, that's going to mean that your catalog strength, whether it be the braking catalog strength or the safe working load catalog strength, you're going to have to reduce that efficiency by 95% and so forth. And it's just another way to build in a safety factor for the fact that sheaves will affect the rope, and there's a certain amount of friction that occurs from the sheave, and that's going to affect that rope and when it would break. Another bit of information that deals with how you go about factoring in loads on these ropes starts on page 7-142. You'll notice there's a diagram on the bottom, and what they're really talking about here is the point of gravity. You'll notice in the diagram they've got a hook and they've got a weight. And if the point of gravity was lined up on a 90-degree angle everywhere, you essentially would say that whatever it was lifting, 100% of that would be the weight applied to the hook. But as you can see, as you move the hook away from the center of gravity, the actual weight upon the point loading is going to be changing. So that the picture all the way to the right, where it's at the very tip edge, you'll notice that the point loading is roughly 41% of what it was at the 100% rating. Now they discuss different types of bolts, the components of bolts, and shackles. And a particular point of information on 143 on the left-hand side, the second paragraph up from the bottom, shackles with crowns or pins worn more than 10% should be replaced or destroyed. Then on 144, they describe spreader and equalizer beams. And these pictures, by the way, are the same pictures that are in the rebar book. And the same kinds of principles are described in the rebar book. And now they're going to talk about blocks and the relationship between the loading blocks and also the angles of lifting items on blocks. And really they get to a discussion on this on page 167, where you see a truck lifting something. And the idea is that these ropes are connected and there are angles represented by these connections across the blocks. And the angles are going to determine how much load is actually being pulled on the line.
Do you want to shut it off or you want me to shut it off?
Look at the example right on the picture. If you look at what they're referring to as B, you'll see that they're telling you that there's a 136-degree angle between the two rope lines on B.
Take it upstairs.
If you look at the table that's there, and look at the 136-degree angle.
No, you don't have to record. You record when I am not around. You
And
can
so if you were
record it at
lifting
noontime.
1,000 pounds under that arrangement, the actual load on the toggle block B would be modified by a factor of 76%, and so your lift would really be 760 pounds. And they show you this in some more examples and give you some examples of how to calculate this. And every once in a while you're expected to calculate something like this on the exam. On 7-147, they now talk about how you set up blocks and pulleys, and they give you a formula for figuring how much pull is going to be necessary to lift something. And some other particular information here, for example, item number 2, as the load moves, the friction of the block sheaves and load flexing across
Do you want to shut it up or you want me to shut it
for
up?
each sheave in the complete width,
I shut it up now.
of the load weight
This will be
must
done
be
in
added
20
to the
minutes.
load. So depending on the complexity, you're going to adjust the safety factor essentially so that you don't break things as you're trying to lift them. On 148, they describe
You're messing
tackle
everything
block
up. Go away.
maintenance.
No, I shut
I'm
it up.
telling Mom what you're up
They
to.
show you some pictures
Hold
of
on.
these things, and then on 150, they show you pictures of
Get out.
different types of hitches.
You shut it up now.
You're
think.
messing up my recording.
Yeah, you shut it
All
up.
of these
I
are
don't want you
components
to
for
do it now
lifting, and the
when
basic
I am.
You can
concept is the
go
same
away.
for all of them. You have to consider the load on them, you have to consider the safety factor, you have to consider the wear and circumstances under which they are being used. On 152, on the right-hand side, they now describe chains, and then they continue by describing how to inspect chains. And then we get to 154, and here again, they're going into how you calculate the effect of angles on lifts. But here they're talking about slings. The concept is the same, but the application is a little bit different here. The pictures are pretty self-explanatory, and they're modified by a table on 155. And they show you how you would adjust different factors for lifts. On page 156, they show you hand signals. These are not asked about much on the test. And then we get into a series of appendices. The first major appendix is the effect of angles on sleep. It's a more complete statement of what they were trying to express in the last couple of pages. Then I'm going to show you some other pictures of slings on page 4, choker hitches. On page 5, they show you Flemish eye knots. On page 6, single rope legs. And then on 7, Flemish eye splices. And they go forward.